look at this problem here, number 41. Okay, this problem, what we're dealing with is this tract, the total perimeter of which is 1/4. Now, what makes up the perimeter? Well, first off, we have these straightaway lengths, which we're going to designate as x. So certainly the perimeter will have two of those, and it also has two semicircles of radius r, which is an entire circle, which is, okay, 2 pi r, and that's said to be equal to 1/4. Okay, so that's one working equation. The other equation we want to look at is the area of the field, the area. Now, in terms of the area, I think you should agree that the area is going to be made up of a circle, which is pi r squared, plus a rectangle, which is the dimensions of which this length here is 2r. So the rectangle would have the dimensions of 2r by x, so its area would be 2r times x. Okay? Now, they want us to express the area as a function of r, so we need a of r, which means, okay, we can't have x in our area function. So we come back to this perimeter and we solve this for x. So we should agree then x is going to equal 1/4 minus 2 pi r and a half of that. So we're getting x equaling, we're going to get x equaling 1/8 minus pi r. Okay, so we're going to come down to our area function, and we can now write the area as a function of r. We're told it's pi r squared plus 2r times x, where x is, of course, this 1/8 minus pi r. Okay? And so now what are we going to have? We're going to have, okay, pi r squared plus 1/4 of r minus 2 pi r squared. Okay, and we should see here that we are now having, okay, a common term with the pi r squared. So it's 1 pi r squared minus 2 pi r squared, so it's negative pi r squared plus 1/4 of r. Okay, and that's our function a as a function of r. Now, the most interesting thing about this right here is that you should agree this is quadratic. So if it's quadratic, r can be determined by negative b over 2a, which is to say, okay, negative b, that's negative 1/4 over 2 times negative pi. So that you should be able to see will give us an r value of 1 over 8 pi. Now, okay, so if I wanted to know what were the dimensions of this field that would optimize the area, okay, that was giving me the greatest area, that's with an r value of 1 over 8 pi. But now what's the x value? Well, if you come back up here, we have x is equal to 1/8 minus pi r. We just determined r is, okay, 1 over 8 pi. Now look at this. This is very interesting. It becomes 1/8 minus pi times 1 over 8 pi, which becomes 1/8 of 1/8 minus 1/8, which means it's 0, which means the area is optimized when this is a, the the area is optimized when, okay, the figure is a circle and there's no straightaway lengths because we've just illustrated that that's optimized when x equals 0. So a rather interesting problem. Sorry for the interruptions, and that's that.